You can see the screen, right?
Yes, sir.
Yes, sir.
So in our last class, where I taught basically the reference and the use of reference, and so meanwhile, I think Dipanita, she has started the basics of class and structures and how to access different members of a class, all the syntax and all this. So in this particular class, I'll be focusing on so kind of summarizing some of those, and mostly I'll be talking about one specific or a kind of special operator which we often use while writing class definitions. That is a scope resolution operator. We'll see the use of that, and I mean, apart from class also we can use it. So we'll see the use of that particular one, and then uh, I'll try to write the basic structure of a stack class, or I'll try to define the stack class. Okay, by encapsulating the relevant methods and all. So we'll see the syntactic overview of that. So the first thing is, we have completed the pointers part and the reference part. So maybe we'll talk about these pointers and classes and how the pointers related to classes and all this before we switch to that stack. So here, okay, so first thing is when you write a structure, let me take this example. So you are all aware of structures, right? And that has been taught by Dipanita. Structures in details, structures in C++.
Yes, sir.
So here, let us assume that, okay, so in main we have got so I think you can see. So this is, we have already talked about the syntax. So this XYZ is a structure. So this we are trying to define it as a new user defined data type. Now, what is the basic difference that we can see in the very first line in declaring a in defining a structure compared to C? What is not required? Something we may skip. What is that? Here you could write something in C. Can you recall?
Type def.
Type def. So type def is not required. So even if you don't write type def, you can still create X and Y. So what are these X and Y called? What are these?
Objects.
We can call it object. So we can call it structure variable. Because it's a structure, we can call it structure variable or object. Doesn't matter. So object instances. Okay. So now, if I have got another XYZ, what does it mean? What is P?
A pointer to an object instance of XYZ class.
So P can point to any object of type XYZ. That's what it means. P is a pointer of, you can point to any object of type XYZ. And what I have done, I have initialized it also with the address of X. So if I consider that so where from the space for X, Y, P will be allocated? Which segment?
Stack.
Sir, X and Y from stack. P
and
also from stack.
P also from stack, because all these three, X, Y, and P, these are all local to main, and they are non-static. So they should be all from the stack segment. So how much space X will require?
Int plus float, the
In
size.
plus 4. So let us assume that so both requires a 4 plus 4 or maybe 2 plus 4, whatever. So this is the space for A and this is the space for F, and this together forms the structure. Okay, so this is known to us, and say this, the whole thing is known as X. So this is labeled as X in the symbol table that has got the implication. And when we, and this P, so P will also require some space, additional space. So this is say P, and if this address is say 20097, the base address, so it will store 2007 so that we can point to this one. So similar to that of structure variables, we can create a pointer variable which can point to these objects. So now we can talk about pointers to objects or pointers to instances of structures. Okay, so this is a structure definition. Now if I would like to access, so what is X? X has got integer member and a float member. So if I would like to access the member A of X, what should I write? The contents of that?
X dot A.
X dot A. So these are all same as that of C. So there is no problem here. And I write X dot F. So it will work. Now if I would like to access the same A via this P, what should I write?
P arrow A.
So first of all, P means you are just having this address or you are outside the box. If you write asterisk P, that means what?
X.
X.
So you can have access to this. So you have opened. So you can think of that this is a box which has got two items. It has packed two items, A and A, one integer and one float. And if you write asterisk, so if it is just P means you are outside the box. If you have asterisk P means you have just broken the seal, and you can now access any of the members if you want. So if I would like to access A, the member A, this is how it is done. If I would like to access the member F, then again P outside the box, this you are just inside and you are trying to refer to that member F. Do you all agree with this?
Yes, sir.
Yes, sir.
So this is again something very much similar to that of C notation.
Can you repeat this once again?
Yes.
Asterisk P.
So asterisk means what? If I say asterisk means, if I
Access.
think of, so if I think of a box, I mean like conceptually, if I think of a box where this is A, this is F, so this is the structure. So this is what X is. Okay, so this is the structure instance A, or the structure variable, or the structure or the object X, which has got two members, an integer member and a float member, right? So now if using the name of the object you would like to refer to any of the members, what should I write? Just dot operation. Okay, so if I have got some other pointer which is actually pointing to the base address of this entire structure, so using that pointer, how do I access that? So if I write just P, P means I'm just outside. So P means I'll be here. If I write here asterisk P, that means what? That means you have just, so now you are inside. So you can think of that asterisk P means you are here. Okay, inside. So you can access either this or this, doesn't matter. So again, now it's your choice. So if I would like to access that member A, So to specify a particular member, what is the notation? It's a dot notation, dot A. Or if I would like to access the other member, what should I write? Asterisk P dot F. Is that fine?
Yes, sir.
So first you think of this asterisk P, you break open that seal. So you can access any of the members of that box. Now which member? Just give a dot and specify its name. That's all. Is that fine?
Yes, sir.
So now, but this can be written in a more compact form. This is equivalent to writing as cout, or if I write it here, just below it, it will be P arrow A and P arrow F. So syntactically, both are same. This or this. What the point? So these two exactly mean the same, and these two exactly mean the same. Is that okay?
Yes, sir.
So either you write this or this, doesn't matter. So P arrow means what? So P arrow means P is a pointer to a structure variable or an object, and using that arrow operator, you are referring to a specific member of that object. Is that okay? So this is more explicit. So the first one, in the first case, you are having more explicit notation. Okay, so in this case, you are more explicit, and it is a bit more compact. That's all. Is that okay?
Yes, sir.
So now let us come to the other case. Okay, so let me, yeah. So now let us write two functions. Okay, so let us write two functions. The function 1, and here, and say within the same main that it continues. So we have got xyz asterisk p, which is storing the address of x, where x is an instance of xyz. So now I am calling fn1, and it is returning basically void right now. So what I am passing? I am passing here, say, address of x. Okay, now I'm passing, and now I'm passing, sorry, maybe 2. I can have the same name, so let us ignore that fact. So these are three things. So what is my intention here? Call by. In the first case, what is my intention?
Call by address.
Call by address. So we are basically passing the address while we are calling. So it's call by address. What is the second case? Calling a function by passing the
Value.
Are you sure it is value?
We have to see the function first.
Yes, it can be passing the reference also, because both syntactically appears the same, right? Can you recall? So this can be, say, or maybe that this is called by reference, because we don't know until unless we see the function definition. Is that part fine? We have already discussed about it. Any doubt? Hello?
Yes, sir,
No, sir.
fine.
So now this is called. So let us assume that our intention is this. So if n1, what should I write here? So the same thing, but I would like to talk in terms of objects, pointers to objects, reference to objects, like that. So if it is called by address, whose address I am passing? Whose address I am passing?
X.
Now, X is an object. Some object's address I am passing. So who should be there to hold it?
A
Here,
pointer of type XYZ.
pointer, say this is say P or something else, say Q or say P. So P should be a pointer which is capable of pointing to
XYZ.
objects of type XYZ, so that this address of X can be, so it can hold the address of X, right? So if you declare P like that, only then it can store the address. So this address may be 2007 or whatever. Now, once it is having that, within this, if I would like to update the contents of the members of that object X, is that possible?
Yes, sir.
P is having the address of that box containing A and F, just the previous case, A and F. P is having the address of the box containing A and F. Okay. I would like to update the members, the contents of the members, so the values of the members through this P. Can we do that?
Yes, sir.
So what should be the syntax? I would like to update. So asterisk P breaks open the seal, then dot A. That means what? I am referring to the integer member of that, and I am writing here plus plus. Is that fine? Got this point?
Yes, sir.
Or I can have that compact notation. What is the compact notation? Instead of writing asterisk and then dot, what can I write for B? For F, what can I write?
Array.
P arrow F.
Arrow.
Okay, so both way it is possible, but the thing is, because P is storing the address of that object X, you can do that even from within this function F1, right? So that is fine. Now if I would like to implement the function 2, what is my intention? As I mentioned, it's called by reference. So what should I declare here to get the reference of a, whose reference I'm passing? The reference of an object of type of this XYZ class, right? So what should I write here? What kind of variable I should declare here?
XYZ ampersand P.
So it should be a reference variable, right? So a reference variable, let the reference be called as Q. I'm assigning a new name to that locally within this function. How should I create reference? This is the syntax. This is a reference of what type of data? This type of data or this type of object, right? So if I do that, now this reference of X, so X Q can work as a reference of X within that function. Is that fine? Right? So earlier we used to create reference of integers or float variables. Now we can create, in similar way, we can create a reference of some objects of user-defined classes also, or structures also. Is that okay? Hello? So if I would like to update through this queue, if I would like, first of all, can I update the contents of the members of X? What are the members of X? This A and F. Can I update the contents of A and F if I have the reference?
Yes,
Yes.
sir.
This is possible. We found that. So how to do that? Because Q is just a new name given to that X. So how can I do that? How can I refer to that member A through Q?
Q dot X.
It is just Q dot A, right? There is no complexity. Because you are just willing to use a different name within this function instead of X, because X is, the use of X is limited only within this main function because it's local to the main. So you cannot call it from here using that X. So that's why you have just passed the reference and you are trying to call it as Q within this function. So I can just write Q dot A. So Q dot A will work, right? But if I would like to update, then what should I do? Q dot A plus plus. And then in the same way, Q dot F plus plus. Is that fine?
Yes, sir.
So both of these is capable of updating. That's the point. So both of these are capable of updating the members. Members of what? Members of an object. Both the call by value, call by address, and call by reference. But which one looks compact and more readable?
Function
Different.
2.
Definitely the second one, right? So this one we prefer. We actually prefer this one because you see it's just q dot a plus plus, but here we have to write asterisk p, then parentheses, then dot a parenthesis plus, and or you may even write this one, but at least using arrow and all this. But it's as simple as that. So as simple as writing just like this: a dot x, x dot a, x dot f, like that. So can you see that the increase in readability of the code? So definitely we would like to have this syntax over this syntax, or this syntax over this syntax. Is that fine?
Yes, sir.
So again, now the point is, whenever you require some members of an object to be updated or to be modified while you are calling a function, so which particular uh, calling say mechanism you will use? You will prefer?
Call by reference.
So we can write here, always prefer call by reference over call by address, because if your intention is to modify. So this we basically no longer use from now onwards, because unnecessarily we just lose the readability maybe. Okay, so what is the last what about the last one? The last one is call by value. So in call by value, what we do, so we have got fn3 and we are just passing the value of x. What should I declare here?
XYZ R.
So xyz, maybe something else, pq r or whatever. What is this r? So this r is just another object which is locally defined in this fn3, and it will get the value of this. So it will get the value of x, and here we got the value of sorry, we got the reference of x, but here we are getting the value of x. So if you are getting the value of x, so definitely we cannot modify. There is no question about doing that. But my question is, can I rewrite this? Try to listen to the question. Can I rewrite this part with something else which will have the same impact? So here, if I write here cout q dot a plus plus, will it be allowed? This will not be allowed, right? Sorry, r dot a plus plus. Are you getting my point? Because it is passing by value, so cout r dot a plus plus will not be allowed. Do you all agree?
Sir, why not allowed?
Sorry, I mean, uh, just a minute. I should have. So it will be allowed, but the impact will not be there. So
Yes,
the
sir.
question is, the impact, sorry, will not be reflected. Okay, reflected in main, right? That's why you do this.
Yes, sir.
So now my question is, can I, instead of doing this, can I do something else here, having the same impact? Like, can I declare some reference variable here in such a way, or I mean some reference here in such a way that still we can do this, but the impact will not be felt? Are you getting the point? Can I declare some reference, PQR, say maybe S? So instead of doing this, can I do something like this, which will have the similar impact?
So we can give a const reference.
So this also will be type of XYZ, but now if I write here const, where should I write? Why should I write where should I write the const keyword?
Before XYZ.
What the point? Can everybody see this? Can you all see the impact? So this is const xyz asterisk this. So if I do this, what does it mean? S is also a new name given to that x, but through that s you cannot update this. So these are not possible. So this will be strictly prohibited. Okay. So like display function, as I mentioned earlier also. So if it is a display function, we may not pass values. Instead of passing values, we can pass it as a reference to a constant object. We can pass it like that. So the only subtle difference is here locally also you cannot modify, but if you pass value, at least you can write here cout r dot a plus plus. That is possible, although the impact will not be felt. Got the basic difference? Got the difference between? So difference between call by value and uh, the constant reference, having a constant reference. Got the basic difference? So none of this will allow you to have the impact, but in the first case you can at least locally change, although it will not be felt. But in the second case, nothing will be done. Neither locally you can change it, nor you can have the impact in that object itself. Is that part fine?
Yes, sir.
So all I try to make sure is how I use the notion of reference when we are creating instances of a particular class or structure in terms of object or say variables, and how I pass and all this, what is the impact. So one thing that we all agree, or we at least accept, that don't pass addresses from now on. If you really require, you pass reference, and if you are sure that you do not want to, you would not like to feel the impact of it, just pass, then also pass reference as like this one, but make sure that it refers to, or it treats the object as constant. That's all. So what I would like to say is try to use reference as and when required or as possible, until unless you are forced to do something else. That's the point, while you are passing arguments to function calls. Okay. So scope resolution, how many of you have used scope resolution operator in C++, those who have done?
Yes, sir.
Yes, sir.
Okay, so let us see what it is. So scope resolution operator, it looks like this. Can you see? So you have
Yes,
to
sir.
give this colon twice, two colon, together it becomes a scope resolution operator, as like plus minus and all this. So we'll see that what's the purpose of it. So now here, so let us assume that we write here a equals to 10, and then here it is main void int a equals to 5, and then cout. So now if I write here cout a, what do we expect? What will be the output?
5.
Is there any doubt about this? Any doubt about this?
No, sir.
So this is basically global, and this is basically local. So when I just write this, so if you have already declared something as local, within the local scope, if you have got something, within the local scope, so if you just write the name, it will write that. But in presence of this local scope or local a, if I would like to refer to this global a, in C, is it possible? If you are dealing with C codes, pure C codes, so if you have written a local A, or if you have defined a local A, declared a local variable named A, and you are also having a global variable A, so if you just write print A, so it will print 5, the local copy. Can you still print the global copy in C? Is my question clear? Are you getting the question?
Yes, sir.
Yes, sir.
So global copy, where it is saved?
Data segment.
Data segment. And local copy? Stack
Stack.
segment.
Stack.
This is A. So this A equals to 5 is here. And this one, in data segment, we have got the A equals to 10 because that's a global copy, right? So now if I write within that function, if I write this, so it will always refer to the local copy. So can we have can we display the contents of the global copy also in presence of local A?
Yes, sir. By using scope resolution.
So that is where it's possible. So in C, is it possible? In C,
No,
is there
sir.
any mechanism?
Sir.
Hmm?
No, sir.
It is not
So
possible.
using
Using
extern, is it possible, sir? Extern.
have you checked that?
No, sir.
So check it and answer. So here in C++, we have got another I mean some ways of doing this, right? So can you see, all of you see? So if I write, so this is the operator that we just now introduced, is scope resolution. So scope resolution A means now it will display, what do you expect? It will display 10. Is the difference clear?
Yes, sir.
Yes, sir.
That's why it is basically known as scope. So scope resolution means it resolves the scope. So there is a scope ambiguity in the scope. So you just write A. So A means which A, global A or local A. So there is ambiguity. So it resolves the ambiguity. So this is the operator through which you resolve the ambiguity. So if you use this operator, it will resolve, and it will basically, no matter what you do, it will always refer to the global copy. Okay. And if you do not have a global copy, and if you write scope resolution A, what is going to happen? Say if you are not having this declaration, then what do you expect here?
Error.
Error, because this scope resolution always refers to the global copy of in this name. If you don't have, it will say that you don't have a global copy, and why you are asking to display the contents of it. So it will only work, and it will always work to access the global copy. If there is no copy, it will give an error message. Is that fine?
Yes, sir.
Now let us go a bit one step ahead. If I write this, will it work? Will it be allowed?
No, sir.
Can you write this? Can you write this? So what you are trying to do within the same scope. So this is a scope, right? So using this, so what is the scope here? So this is a scope, right? This blue one is a scope. So within this blue scope, what you are trying to do, you are trying to declare two variables with the same name. Will it be possible?
No, sir.
So this is the same, maybe the CSE branch. So in the CSE, the entire CSE batch, if I have got two students with the same, exactly the same name, it will be a clash and it will be difficult to resolve. But if I say this one, will it be allowed?
Yes, sir.
What is it?
Yes, sir.
What is this? Now
Block.
for pure
Scope.
C programmers, so for pure C programmers, can you see these two? So can you just write? So when you are writing a function, you can write this one. So when you are writing a new function, so then this is possible. So you start with it and you end it, and you create a, by default you create a scope. Now within a function here, if I create several such things, are those allowed in C? Can you create a scope within a scope in C?
No, sir.
In pure C, this is a blue scope. Within the blue scope, if I would like to have a green scope, is it possible?
Yes, sir.
In C, pure C. Probably you have not used the pure C compiler. It is not allowed. So all you are using is more or less C++ compiler and used for C coding. So if it is a C compiler, generally additional scopes, or scope within a scope are not allowed. So if you write a for loop, that is fine. So you can write a for loop. But again, in C, the first thing is in C you have to declare all the variables in the top before any. So in a function, if you are writing a function here, so all the variables should be listed here, right? Variable declaration, and then comes the actual executable statements using for loops and whatever. That's a different kind of restriction at all. So you really cannot declare them anywhere. But in C, it is not only that you can declare the variables anywhere you want, but you can create a scope within a scope. So this you can, I think you can see. So this is a green scope created within the blue scope. Is that fine?
Yes, sir.
And if you have created that, then probably this also will be accepted. Because all you say that in the outer blue scope, you have got a local variable A, which initialized 5. But in this green scope, within that blue scope, you have created another local variable A, whose value is 9. So what do you think in the stack segment? Will it go for another allocation of A, or will it just modify the contents of A?
Another allocation.
Another allocation. So it will be probably it will be something like this. So A equals to 9. Got the difference? Hello?
Yes, sir.
Yes, sir.
So now if I display the contents here, what do you expect? And the contents here?
9, 10.
9 and 10.
This is 9 and this is 10. So this is always 10. There is no matter what you do. It will always refer to the global scope. It will always refer to the global scope. But what about this one? This will always refer to within the local scope. Try to resolve it. Is that okay?
So can we access that A in the blue scope from the green scope?
You cannot do that. So you can do that only if you do not have this. Okay, so how should I write it? So the point is okay, something like this. Let us create one more scope, maybe the yellow scope. So after the green scope ends, I create a yellow scope. I think it's difficult to see. Say a black scope. So a black scope I create, and in the black scope, I just write cout A scope resolution A endl. Can you see this? So did I create any declaration here within this black scope?
No, sir.
No, sir.
So now if I want to display this A and this scope resolution A, so do you think it will be error message here?
Sir, it would be 5, I guess. 5.
Yes. So then comes the point. So if you have nothing within your local scope, it will go out, and if it is a nested scope, it will check the outer scope if there is a definition of a declaration of A. If it is not there, it will go even one level outside and check. And if it is no such local, any of the local scopes are given, it will give an error message. Is that fine?
Yes, sir.
Excuse me, sir.
Hmm.
Hello. Sir, Sir, suppose in the main we do not declare a int a is equal to 5. Then what should it print in the second block? Should it
If
print
we do
10
not have,
or
if we do not have a equals to 5, means
in
we
main?
don't have any local scope.
Yes, sir.
So if I write C out A, what is the case? So it will
Okay,
be
it should be
the,
print 10 now.
it will display print 10, no problem.
Okay,
But
okay, sir.
if there's a
I was
clash,
confused.
then that scope
Hmm.
resolution helps you to resolve.
Okay, thank you, sir.
So here you got the point. So if I write here A, so there is nothing in that in its own scope. So it will go outside and outside and outside till it gets something. If it is not there, so so there will be a message like that. So here you can say that this will probably refer to this A, because it has nothing here, nothing declared within the black scope. Is that okay?
Yes, sir.
And now if I say, for example, if I have written something like this, int, or say, sorry, this let it be like this: int A equals to 12. Where do I write? Where do I write int this thing? Got it? Int A equals to 12. I wrote it within the black scope, but after this cout statement. So then what do you think? What this black A will print?
5 only.
5.
5. So it will basically not look downward, rather it will look upward regarding any declaration. Is that part fine? So this A equals 12 will basically be, it's of no use, because after we have declared, we have not accessed this local copy of A. And before we have declared it, that means in this particular line, before we have declared it, there was no declaration, so it would have accepted the previous declarations, if there are any, within its scope or within its outer scope. Is that part clear?
Yes, sir.
So just like if I call some name, say something like Akash. So if somebody is there with that name Akash, so see, he will respond. If it is not there, but still I am keep calling, so you will say that okay, he might be referring to some other students in some other departments, like that. Okay, so or maybe in the some other students in the same department but in some different year, like that. So you'll just try to refer to the name in a slightly outer scope, but in the same CSE. And if there's nobody found in CSE, they will say that still he's confident about there's a name, so let us look in some other departments other than CSE, like that. Is that okay?
Yes, sir.
So this scope resolution is really useful, and I think now this becomes redundant, so you'll be able to solve it. So these are all trying to play with this. So what will be the value here? What will be the value here? I think you can just, so just can you quickly tell me what will be displayed here? Quickly.
20 and 10.
20, 10,
20 and 10. What about here?
30 and 10,
30 and 10.
And what about here?
20, 10,
20 and 10. What about here? This one? This one also will be the same thing, right? Okay, what about this? It is 20 and 10. What about this one? It will be line number
20 and
11.
10.
2010.
Again 2010, because if you move up, there is nothing declared here. But here you have declared, and now if you write here, what will display?
3010.
30 and 10.
30. So you see within the same scope. So these two statements are within the same scope, this scope. But one of them displays 20 and the other one displays 30, because they are using a different declaration depending on the position. Is that fine?
Yes, sir.
And these two will be again the same. So this one and this one, it will be 20 and 10. Okay, what about this one?
20, 10.
This one?
20, 10.
And here?
30, 10.
Line 14. Because the immediate one is 30. This one?
30, 10.
This?
30, 10.
This one? Still it is 30, 10 because there's nothing here. And then you have defined this x equals to 40, but it's of no use because after you have defined, you have exited that scope. So it becomes invalid. It's of no use practically. So now what about this one?
30 and 11.
So you basically, so this scope you can ignore because this is already nested in it. So you have to come out of this and see. So which one you find? You find here 30. So this will be considered here. What about this one? What does it mean? The global copy of x, that is 10, is incremented by 1. And you are displaying. You pre-increment, you increment and display. What is the value?
11.
11, right? And what about this 2? So when you consider this one, so you basically consider, so you have to skip. So this scope is completely over. So you have to come here and you are trying to access this one. So what will be the value?
2011.
Hmm?
2011.
2012.
20 and 12 because we have again incremented.
21. 21.
Fine. So that is how it works. So this is a summary. A pair of parentheses can be used to create nested scopes within a function body. And in C++, you can create many such scopes, nested scopes. So nested scopes are possible. And this operator can be used to access the variable in a global scope, mainly used to resolve conflict when there exists a variable with the same name in the local scope too. Okay. If there is no global scope declared, and the use of this displays an error message. And one can update the global variable to that is using this or this. That's we just now shown. And whenever we access the local copy of a variable that is without this scope resolution, the compiler moves up to find a local declaration of the variable within the current scope, or it scans upward. It scans only upward, not downward, to find a local declaration within its outer scope. So that is what we have just now found, right? It just summarizes the entire discussion. Is that okay?
Yes, sir.
Okay, so how much time is left? Do you have any more time left? Otherwise, what's the time now?
53.
Yes.
Okay, so I think if I start now, it will take another half an hour. So better I do it in the next class. So the idea is in the next class, I'll try to write a stack data type using a C style. So C style means, you see, it is not encapsulating things. So without encapsulation. So all the functions or the methods, whatever you say, all the procedures, none of them are encapsulated together. So that's what we have done in the last semester. So a bit better version is, can you see? I mean, we'll have the details of it. We can encapsulate them within the structure definition itself. And then how to access it and all these details we'll talk about. And now this is another one where we just use the scope resolution. So these things we'll do later on. Okay. And then object creation and all this. What about those assignments? Have you solved assignments, the last set of assignments?
Yes, sir.
Yes,
So
sir.
those were not done. And I think those are all just a bit modification of the previous assignments that you did in the last semester. The only thing is you have to use C++ syntax, the new operator, the wherever you are trying to deal with strings, you have to use the string class. So just write string and see how it works. You can check in Google the different string classes, or you can see the details methods that are supported by the string class for performing concatenation, then substring matching and all this. It becomes extremely simple. So that's why I wrote that. And then in the determinant, it is almost the same, but you try to use as and where possible the use of reference. Okay, so that's why I mentioned there. And finally, after doing a little bit of these structures and classes and all this, so one concrete example that we'll try is to implement a linked list using C++ concepts that we discussed, using the class concept. So how I write it, right from a node class, a linked list class, then implementing hashing. So hashing, I'll come across hashing in that flow. So we'll be talking about that. So how we compose new classes using existing classes, uh, how we compose, how we reuse those classes, that we'll see that syntactically, both syntactically and in terms of the design. Okay, so that part. And then once that is done, I think once you know how to write linked lists, how to write hash tables using linked lists class, so you will find that it becomes extremely simple. So a few lines of code, you can write a new class like that. So we'll also write the graph class, the implement the graph, the graphs. We'll have a basic theory of graphs, and then we'll implement that. So that way, I'll have a few more assignments on graphs and hashing and linked lists. And then we'll again try to know more about this polymorphism, function overloading, operator overloading in details, not just the syntax, how it implements, what are the issues like that. Okay, any questions, any doubts till this point?
Sir,
Hmm.
sir, please explain assignment 2D, sir. Means question number 4, sir, of assignment 2.
Assignment 2, question number 4. What was that?
A string, sir, indented a string question, sir.
Indentation.
Yes, sir.
Indentation, I think I gave an assignment in the last semester itself, right? Indentation. I think many of you have solved
Yes,
it
sir.
also.
C.
Yes, sir.
Indentation. Indentation means in a code, when we write a code, uh, we give some initial tabs, right? If I write a for loop, I give a parenthesis. Then if I write some statements, I give some tabs, and then I write that. That is called indentation. Are you getting me? Who
Okay,
was the
sir.
question?
Yes, sir. Yes, sir.
So generally what we write, sometimes what happens, programmers, they don't care about readability of the code. They don't write properly documented and indented code. Documentation means giving comments, so that there are enough hints what this portion is doing, what this function is doing, what this loop is doing, and all this. So some kind of description of the logic, that is called documentation. And indentation means yeah, so if you start each and every line from column 1 or column 0, then what happens, it becomes very difficult to read. At least whenever you have got nesting, it becomes very difficult. Or whenever you have got these multiple scopes, if you do not indent it, if you do not give tabs, it becomes very difficult to read. So the objective was, if I give as an input an unindented code where all the lines start from the column 1 as a text file, if I save it maybe at .txt or .c, whatever. So your C program should, your C++ code should be able to open that file, and then perform the indentation. Whenever it gets a opening parenthesis, it will give a tab. Tab means what it should do. So tab can be so you can consider a tab string. So a tab character followed by a null character. That means a tab string. Are you getting me?
Yes, sir.
So if a particular line is just following a particular opening parenthesis, so that must have a tab before it starts, right? So you have to basically insert a tab means 8 characters, 8 blanks or maybe 6 blanks, whatever. So when you know strings, what you do, you basically form a tab string. What is that? Slash t, it's, so slash t followed by uh, this null character, so that becomes a tab character. And the tab character you can append it in the beginning of the string, so you can concatenate that tab string as well as the original line, so that if you next time if you display, it will give some space before it. Okay, so today I think the time is up. Maybe in the next class I'll take 5 minutes to discuss that, to show it how it works. But I would suggest you to try, because I'm not sure whether you have done that indentation code in the previous semester. If you have not done, you try to do it. But the only thing is you have to use the string library here, so it becomes much easier to deal with that, to deal with strings in C++. If you are not getting, so maybe you can remind me in the next class. I take 5-7 minutes to discuss that part,
Sir,
because otherwise
hello.
others will start shouting that you are getting exceeded the time and all. Yeah.
Sir,
Yes.
can we use setw to indent strings
setw
and
setw
set
is meant
fill?
for displaying it in the, setw you can do, but you cannot. So if you directly open it in the editor, how the setw works? Setw is for
Sir,
temporarily displaying it in the monitor. That's fine using
no,
cout, but the thing is
sir, I am
using,
outputting in a file. No?
yeah, that is possible, so see, displaying, putting the things. So what is this monitor is in C++. Monitor is also treated as a, uh, it's a file, it's a kind of file, where you write. So it will treat input or output device as a file, uh, um, as if you are writing it in a file. Are you getting the point? So
Yes, sir.
when you write cout this, that means you are directing it to the printer. But instead of a printer, if you can direct it to the output file that you have named, setw can work.
Yes, sir.
But
So,
those
sir,
who do not know how to treat the so this things as a file, so that's why I asked you to just do it in a simple way. Maybe later on, if we deal with C++ files exclusively, then we can try those things.
Sir, in
And otherwise,
assignment, I think you have mentioned file.
yes, I have mentioned file, but I have not asked to do using setw. So you could have done it
Okay.
by inserting tab strings,
Okay, sir.
appending tab strings in the beginning. But you have to deal with files. That's fine.
Okay, sir.
But instead of setw, you can use it. You can consider appending tab strings. Tabs. I mean,
Okay,
to create small strings of tabs, and then concatenate it with the